All right, here we have another thing to prove, another example. And in this example, I'll explain some things that come up in the class and do come up in, will come up in later classes, as odd as they may seem. All right, so first thing is, what does this symbol here mean? This is the power set. Okay. So the power set is the set of all subsets. Okay, so let's say that A is the set 1, 2. Let's see, the subsets. The subsets of A. Remember, the empty set is a subset of all sets. 1, oops, 2, and A is a subset of itself. So I could write just A here, or I could write out the set containing 1 and 2. Okay, so then the power set of A, of course I'm not going to have enough room to write it there. How silly of me. All right, but I've got plenty of room here. Haha. All right. The power set of A is the set whose elements are the subsets of A. So okay. That's the power set. Mm-hmm. Okay, so in this one, what we're going to do is we're going to prove that we're going to prove an if-then statement. We're going to prove that if A is a subset of B, then the power set of A is a subset of the power set of B. I guess that's somewhat intuitive, right? If A is contained in B, then all the subsets of A should be contained in all the subsets of B. Okay. All right. So now saying this is really the same as saying this. So we're going to actually prove this statement here. We're going to prove that if X is in the power set of A, then X is in the power set of B. All right, so how do we prove a conditional? We assume the if part, show the then part. All right, so assume X is in the power set of A. Now, of course, you might be saying, how can we assume that? Remember, like I talked about in the previous video, the reason we can assume that is if that's true is if it's false. If it's false, then this statement is immediately true, right? So if you have false here, then it doesn't matter what you have here. The whole thing is going to be true. So we may as well assume it's true. Okay, assume X is in the power set of A. So what does that mean? Right, remember the power set of A is the set of all subsets of A. So if X is in the power set of A, that means that, let me use some grammar. So that means that X is a subset of A. All right. So now you might be saying, okay, so what if X is a subset of A? How do I get that X is in, right, the power set of B, right? You might want to, what people might do, they might say, what do I want to show? What WTSs want to show? I want to show that X is in the power set of B. Okay, well, what does it mean for X to be in the power set of B? That means that X is a subset of B. Okay, so what I really want to show is that X is a subset of B. Okay, so what I want to show, right, is that X is in B. What does it mean for X to be in B? It means that X is a subset of B. Because what are all the elements of the power set? They're all the subsets. Okay. All right. Now, when you're doing a proof, oftentimes, if you haven't used the assumption, then that gives you a key of what you need to do, what you need to use. So we haven't used that yet. So how is that going to help us? All right. So let's look at this. And say that this is A. This outer box, the outer box is B. This inner box is A. This is saying that A is a subset of B. Everything in A is in B. Okay, so now what we have here, right, is that X is a subset of A. So X is a subset of A. So X is a box within A. So a box within A is a box within B, if A is within B. Right, so it's box within a box within a box. If A is a box within B and X is a box within A, well, that means that X is a box within B. So I'll write that. Since A is a subset of B, X is a subset of B. Now, if X is a subset of B, that means that X is in the set of all subsets of B. So X is in the power set of B. And that's it. That's the proof.